So we're starting this problem with a bunch of factorials. We're looking at a sequence that we call S sub n, and we want to find the limit as n goes to infinity of that particular sequence. So the first thing we're going to do is we're going to take our sequence and we're going to substitute everything that represents our sequence in there. Because we have factorials, what we want to do is actually write out what those factorials mean. And this is the best tool to use when you're dealing with factorials, is just start writing that out. 2n factorial means we are taking 1 times 2 times 3, and we're going to use a bunch of dots there, all the way up to 2n. Now I'm going to switch up on our denominator a little bit. What's going to happen, and I'm going to actually add in 2 elements in our numerator at the end. Sometimes it's better to put a little bit extra in there. It's going to help out. So next up, we're going to take this 2n minus 1 factorial and we're going to kind of expand that. And the reason why is we want this to notice how it lines up. So it really helps us to do that. And then we have a 4n plus 5 that we are also multiplying by. All right, now that it's all lined up the way that we have it set up, we know that things are going to cancel. Our 1s will cancel, our 2s will cancel, our 3s will cancel. In fact, all the way up to the 2n minus 1, all of those things are going to be canceled. And what we're going to be left with is 2n over 4n plus 5. And we can definitely take the limit of that as n goes to infinity. Let's write that out, and then we'll do a little bit of work on it. Now, if you know what the solution is to right off the top of your head as you're looking at, that is amazing. If not, the thing to do is remember when we have n's still available in our numerator and our denominator, we're going to pull out the highest number of n's we can from our denominator and the same number of n's from our numerator. In this case, there is only one n that we can pull out of both sides. And now, of course, we are going to cancel that n out. As n goes to infinity, if we remember our graph of, I'm going to write as y is equal to 1 over n, but this is going to actually work for 5 over n, any number over n, as long as the numerator is fixed, or in this case, x's. And usually it would be x's, I should say. N's are usually for sequences. That is going to go to 0, as we see in our graph. As n gets bigger, our number gets smaller. So that is going to go to 0, which leaves us with 2 divided by 4. In other words, our solution is 1/2. Thanks for listening.